I'll be monitoring the chat.
Oh, okay. So when we do other events, we find Q&A works really well just because it's going to be a little different than the stream constantly of the chat, but it doesn't matter for this one.
And I see your recording, so
Okay.
that's good.
All right. Hey, Dr. Stein.
Because really that's.
I could sit one seat further away.
Please don't do that. Well, but could you stand with Valerie and show them the book and show them the card catalog before you show the people?
I'm going to go about 30 more seconds and we'll get started if that's okay.
Okay. I'm a ghost.
Don't go anywhere.
Can't stay. You believe you stay?
And then just sign
Yes, I
Yeah.
You can sign in, please.
Yeah, and then you're speaking over soul.
Valerie
Yes,
does
the drawers.
the touchscreen work for slap and slide.
It usually, because it's on an extended monitor, the answer is probably going to be no.
No, not since we're using the
Right.
extended monitor here.
But I don't mind clicking. I'm used to this room, so it's totally fine.
Or do you want me to sit here and advance your slides for you?
That's fine.
Will you be
can certainly
comfortable
do
with
that.
You just have to give me the, no.
Oh, I'll let you know.
Yeah, that'd be great because then you can stay in the frame, 'cause
And I can stay out of the frame. Okay.
unless you stand in front of the camera.
I'll let Valerie do that.
My question for you is audio. Is it working? Because that is not what we have.
Yeah, I tested it this morning. It should be, they should hear you perfectly.
Okay.
Clear.
Great.
And I put in the chat to the folks who are online that if they have any issues with the audio, just let me know.
Okay, great.
But we're ready when you are, Dr. Mercer.
Great, thank you. Well, welcome everybody. Today is a great opportunity on a rainy afternoon to talk about important things like algorithms, which actually run in the background of our lives. And we are presenters who are the second co-curricular seminar, and this is a great opportunity to share what we're doing here at MGA so students and faculty can learn together. So today, Deborah, Stanfield, and I are going to be talking about breaking the code or understanding algorithms. And for my IT majors who are out there and joining us today, we're not going to go into dark data or any of the other things that we do in our area in detail today. So know that we are going to be doing something that addresses algorithms from a perspective of us as consumers and us as users of technology, but not necessarily coders, software programmers, and those kinds of things. So let's get started. We actually might have a question. So I'm Valerie Mercer, and I'm an assistant professor of IT in the School of Computing, and I'm a retired chief technology officer with 23 years of experience in the field. And I have with me a professional librarian, Deborah Stanfield, who is, I love librarians because 2 of my degrees are in library science. And so we're going to be talking about classic algorithms today when it comes to library science. So it's a great connection, and I hope you enjoy our hour together. So a little bit about what we're going to be talking about is the card catalog, which, as I said, is the classic algorithm. And so I am going to turn this over to Samantha Wilcox and Deborah. Ta-da! Okay.
All right, now we're talking. All right, thank you, Valerie.
Come on over.
Well,
I'm gonna have that part.
I'm here. This is Deborah. I am going to co-present with my colleague, Samantha Wilcox. And today we're going to talk about the card catalog, a classic algorithm. We're going to take a step back in time and explore one of the most iconic systems in the history of information organization, the card catalog. Has anybody ever seen a card catalog before? We've got a few that know what this is. That's great. Usually we don't. As early as the 1800s, the card catalog was the backbone of libraries, archives, and information management systems. It served as a physical tool that help librarians and users alike navigate vast collections of books, documents, and other resources. So here's a picture of a card catalog. Inside a card catalog, there were 3 types of cards that were featured. You had subject cards, title cards, and author cards, all arranged alphabetically. Each book in the library would have multiple cards representing it. Due to the vast numbers of cards linked to each item in a library, card catalogs could become enormous. Sometimes they filled entire walls or even entire floors of a library. What was the card catalog meant to do, and how was it related to algorithms? Well, the answer is that card catalogs were essentially a paper-based search engine before digital catalogs. Card catalogs, algorithms, they're related in that both serve to organize and search through large amounts of information efficiently. MGA Library still has one original section of our card catalog. It's in Cochran at Roberts Memorial. Sam's holding actually one of the drawers. Now this is just one. Yep. Now, depending on where you began your research, you would be directed to other cards. Here we have an image of a real subject card, and you can notice that the subject is shells. That's important. The shell you say, remember that. It includes 4 additional references that would lead you to 4 more cards. Any guesses on what might lead you to other cards? Don't be shy. Mollis, all right, so those are subjects, right? I see the subject at the top, subject headings at the bottom, titles. Let's look. All right, you've also got a title of the book. The card on the screen, this, like I said, is a subject card, but the card in the drawer that Sam's holding, and you can pass around and show them if you want to, is an example of a corresponding author card. Here you see the 4 pieces of information that would lead you to additional cards. On this card, we find an author's name, a title of a book, and 2 additional subject headings to explore. This is just a simple example. Other cards within the system may contain numerous subject headings. Now, you may be asking yourself, where in the shell is this book in the library, and what in the shell does QL403A133 have to do with this book? Anybody know? Oh, you're close. Yes, okay, Dr. Savannah back in the back has the better answer. Not that the Dewey Decimal is bad, that's more public library. So what this does, I'll show you basically, letter and number combination codes mean something. Like Dr. Savanovic said, the Library of Congress call number. Librarians use it to locate the physical title of this book on the shelves, okay? And you can see the combinations of letters and numbers organize books. Obviously, shell doesn't start with the letter Q. These letters represent different subjects. Q is science, and the subclass QL is zoology. In our example, the subject card has the same call number as the author card that was in the drawer. The title card would also have the same number. Here we have the book that Samantha's holding. We actually have the book in Cochran. We brought it here to show you. Are you confused yet? Don't be so confused. What I'm saying is, back in the day, before we had machine algorithms, we had to do a lot of things to keep information and books organized in the library. So okay, I have to say, this is the line I've been given. Back in the day, finding one book could take longer than binge watching an entire show of a season of your favorite show. So before the mathematical algorithms made online catalogs a thing, researchers were basically on an epic scavenger hunt in the library. We had to flip through dusty card catalogs, scribbling handwritten notes, all while hoping to stumble upon the perfect resource. But now, this is what we've got at our hands, at our fingertips that we can use. We've got algorithms, we've got Galileo, we've got mind maps. So, should research today be easier? Can I get a shell? Yeah.
Shell, yeah.
All right, in the back, there we go. If you answered shell no, come visit the library. We've got the tech and the know-how to help you survive. All right, Dr. Mercer.
Awesome. I love it. So I can remember learning how to catalog, how to put tags on specific works in school so that people could go and find the books years and years ago. And one book that's got tags to this day is a classic. I chose this one, How to Make an Apple Pie and See the World, simply because this is a classic children's book. And what should be simple, which is the fact that you're going to make an apple pie. This book talks about a child would have to go all around the world. We got to go to Zanzibar to get some cinnamon. We've got to go all the way to Europe to get the best flour. We've got to do all of these things to get an apple pie. And yet their definition of apple pie and your definition of an apple pie might be different. Well, it's the same thing with algorithms. They need to be able to be general enough to be able to handle our information, but also granular enough to be able to define the fact that there are people in Vermont and there are people in the Midwest who like cheese in their apple pie. Who knew? And there are people who don't like a slice of apple pie. They want something they can hold in their hand, which is a classic hand pie. But all of those things involve apples. And so you've got a recipe of how these things should be put together. And what we got to do is turn around and teach the machines not only how to make a traditional apple pie, but how to make hand pies, how to make pies that actually have cheddar cheese in them or Swiss cheese. Who knew? And supposedly they're very tasty. And then there are also different ways that you can make apple pies. But the key to it is that algorithms are mathematical recipes, if you will. And if you want to turn the slide for us, we can see that there are lots of ways in which algorithms are involved in our lives. These recipes have to be understood by a variety of means, and you can turn around and generate lots of things. So algorithms are basically math problems, if you will. And then we add the machine learning that goes with it. And we've got lots of things happening in our lives today, so that we've got things that are happening. Do you want to take it back for me?
I'm sorry.
You're good. With things like resume screening. We'll actually talk about that in just a few minutes. Google search results are basic algorithms from long ago, and they still work sort of the same way. Content moderation, you think somebody's actually sitting there and watching all of those things happen when you get onto a discussion board? No, they're not. And then we've got classic things like Alexa and Siri seem like they've been around in our lives for a long time, but they basically came into our lives in 2012, 2010-ish, somewhere around in there. We have machines that are doing medical diagnostics for us with algorithms. And then, of course, we're going to spend some time talking about social media, Facebook, Twitter, those kinds of things. We also have algorithms that are out there running all the time looking for bank fraud detection. Maybe these are things that are making suggestions for stock trading. And then, of course, the insurance risk management world definitely relies on algorithms this day. And that can affect your rates, whether or not you're eligible, all of those things. And then we get into areas where we are using even less and less human interaction, where we're talking about, and I'll tell you a story in a few minutes. Dylan's actually heard it before. Sorry, Dylan. Where I'm going to talk about Robert Williams and facial recognition from the year 2020. So we have lots of different things that could be happening. Maybe we're going to have some robots happening on our campus maybe sometime. Who knows? But we've got lots of different ways that we're interacting with algorithms. So let's go forward. And I want to talk to you about YouTube, because YouTube's been around since, how long's it been around in our world? Do you know?
2005.
Very good. Oh, thank you. All right, 2005, 20 years old, okay? 14.8 billion videos. And yet somehow when you hop on YouTube, it has suggestions for you of what you should watch next, correct? Has that happened in your life? Okay, great. So I want to tell you about some very new research. University of Massachusetts at Amherst actually published this information in the last week, and that is every single YouTube video has an 11-digit unique identifier. If you and I were to go through and search all of those 14.8 billion videos, it would take, with you and I just taking 3 seconds per search, it would take us 178 years to go and identify every single one of those 14.8, and some people say up into the trillions videos, okay? However, with this algorithm agent that this University of Massachusetts Amherst lab built, they were able to identify all of these videos in less than 3 days. And so now we know most videos are 5 or less views. 4% have no views whatsoever. People are just using it to catalog what's going on. 89% have no likes whatsoever. 74% have no comments. And the median YouTube video has 41 views and typically is 64 seconds long. And all of that is data that Alphabet has never released. To this day, since 2005, Alphabet has never, or Google, has never declared that YouTube actually makes a profit. It is a revenue generator, and they will share that with us, but they do not say that it is a profit maker. That happens a lot in the IT world. For instance, Spotify has been in existence now for 18 years and finally has declared that it has made a profit. And so after 18 years, but my point to you is, with the help of algorithms at the University of Massachusetts Amherst, they were able to give more data than we've ever had about YouTube. And from a consumer standpoint, now you can see a little bit more about why it actually is pushing you to certain videos. It's because those are the ones with the comments. Those are the ones with the likes. Those are the ones that other people have seen. And so that algorithm is making that difference for us as consumers. I'll take us to the next one. All right, so here is a true definition. Algorithms are mathematical objects. They take a sequence of operations and translate them into computer code. They're fed with data from the real world, given an objective to complete, and set to work to crunch calculations to achieve their aim. Okay, so that is their formal definition today. However, if we were to talk about some of the other algorithms that are being developed, then we're going to talk about things like transfer agents and things like that. Then that is a lot more fluid, shall we say. And so those things that are out there, we might get a chance to talk about those, but that would get us into dark data world. So, but that is algorithms. As I said, they're mathematical objects, those kinds of things. Anybody got any questions or any thoughts before we move forward? All right. So I love this because basically somebody wrote the code for a decision tree. Should I go do some research? If so, should I go on campus, off campus? And the biggest thing to discuss or figure out is food. And so this is basically your algorithm of an evening at MGA deciding whether or not to go to the library, or a person's options navigating the library. So this should look maybe not familiar, but you've done it. So have a Starbucks coffee would be my favorite part after I go visit the information desk. All right, you want to take us forward, Ms. Stanfield? Of course. All right, so what tasks can algorithms perform for you as a technology user? It can prioritize for you, which is what Netflix does, whether you have the $6.99 version or the $17.99 version. It's going to ask you if you liked that movie that you got through watching. And if you did, here are some more that work just like it. And based on your viewing history, here are some things that you might like. All of that is not done by Kyle, who works in IT at Netflix. It's done by an algorithm that maybe Kyle's grandfather may have produced, because that algorithm is really old at Netflix. And then, of course, we've got the old-fashioned classification algorithm that happens at Google. If you're an Amazon searcher like I am, and you're a customer on the regular, then of course Amazon is going to make suggestions for you, strong suggestions about what you should purchase and maybe what you haven't purchased based on your clicking history and based on what you do. And then of course filtering. We'll talk a little bit about social media in just a few minutes, but Instagram, it has changed its algorithm over the years, because if you know when it began, which was around 2009, it actually began as just a collection of pictures. And so we know that the filtering algorithm for it has changed tremendously. And we'll talk about curating that and how you can be strong when it comes to social media and your use of it. Okay. All right. So one of the things you need to know about is decision-making algorithms, because they work by taking the characteristics of you, your age, your income, maybe your zip code if you're applying, let's say, for a loan, and reporting back the prediction of that person's outcome, the likelihood that they would default on a loan according to a set of rules. And that prediction is then used to make a decision. In this case, whether or not we're going to approve or deny a loan. Now, here's the thing. This factor right here has actually been brought before the Supreme Court. And when I say I'm pointing, I'm the zip code. And so decision-making algorithms have been questioned and even brought into legal cases, but they are standard operating procedures in IT world in this day and time. Okay. So there are stages of bias that we have, and if you will look at, excuse me, let me see if I can pull up my little notes here. So we've got some different ways in which bias is actually happening. Maybe it's at the point where we're actually collecting the data in the first place, and that bias might be because we didn't get a full representation of full data set. Maybe it's the way we label data. If somebody is labeling data and you and I have different interpretations of what those labels should be, but we're all working in the same pile of data, that can create a bias. We can also train a model, but if we have not done that training data and not balanced it, then it's not designed to do a lot of diversity and it can't handle the outputs that would happen. So we've got lots of different ways that algorithms can actually be biased. If you want to take it forward for Ms. Stanfield. All right, so implicit and explicit bias, the people are behind the algorithms. And so it can be that the person consciously or subconsciously has bias. And so therefore, we have got to make some decisions about the types of things we feed into the algorithms, and that's going to affect what the outputs actually are. Okay. So different types of algorithm use. Amazon got into trouble several years ago because they were using a tool that was algorithm based, and what it was going to do is sort resumes by who was going to be the better type of candidate by the language that was used on the resumes. What they found was that there was a disparity between females and males. Males use language like captivate, capture, and execute on their resumes. The algorithm was built to say those as positives. And so what they found when they got started looking at the actual resumes and who got picked for being a potential employee, they were seeing a large amount of disparity, which actually ended up as a legal case. Okay. So deciding who gets eligibility to social services is another one. If you take Optum Insurance, there was a class action suit because of the fact that Optum had built an algorithm that said people who don't use medical services are more healthy. Therefore, we can say that they need or they should have X type of insurance services or health services. What they didn't take into consideration when they built this algorithm was the fact that a lot of people who are unhealthy can't afford medical services. And so therefore it skewed the data, and the algorithm was not a clean way to make decisions about what people needed. Okay. Determines who sees what kinds of advertisements for jobs, housing, or loans. You and I, based on where you are geographically and holding your phone, can have a different type of result or a different suggestion set come to you simply because of that. One of the things that I teach my students is the fact that employers are looking to choose to hire, fire, and promote based on what's on your resume. And they're looking for more than what's a degree program on your resume. And so one of the things that we've been trying to do in the School of Computing is to encourage our students to have a professional learning section where they show that they've gone to seminars, they've participated in things like this. They can add those things to their resume. It enriches it, and from a machine-based review of that resume, it makes it a richer and more eligible candidate. Okay. We've talked a little bit about housing and risk, and then we're going to talk a little bit about crime and the fact that we have plenty of tools that are out there that are looking for proactive ways to either stop crime from happening or looking at ways to mitigate risks. So take us to the next slide. All right. So we got lots of different AI platforms that are out there that are built on algorithms, Perplexity. Somebody tell me their favorite one right now.
Gemini.
You like Gemini? Okay. Anybody? You like DeepSeek? Okay. I want to know more about your experience when you get into DeepSeek. Anybody else? I like Claude. Claude is my favorite, actually. Yep. Anybody else? Perplexity, I do like as well. So there are lots of different ones. Of course, the one that everybody kind of goes to that's being treated like the Kleenex or Xerox of our lives would be ChatGPT. Okay. So there are lots of people who are using it. But all of these AI platforms are built on algorithms. Okay. So we talked a little bit about bias types and those kinds of things. Take us forward, Ms. Stanfield. We're going to try to get forward. There we go. So algorithms learn rules for making predictions by analyzing what's known as training data to discover the patterns that are involved there. And then from those patterns, it basically makes decisions and predictions based on that. If training data is biased, as we've already talked about, then the algorithm can pick up on that discrimination and replace it in future decisions, and then things aren't as good as they could be. I keep going back to that same example I used before, which is a bank's historical lending data may show it routinely and unfairly gave higher interest rates to particular residents in a particular zip code. Okay. And a banking algorithm trained on biased data learned that pattern and then turned around and continued to perpetuate high interest rates for certain people. Okay. So that has been hopefully handled in court. Take us to the next one. So you and I do something called survivor bias. And AI does the same thing if we've trained it that way. We remember the good things that happened. And we also remember the notable things that happened. We talked about card catalogs. We talked about YouTube. Let's talk about Wikipedia for a minute. How do you get to be an article on Wikipedia these days? Do you know?
You have to be a contributor, right?
You have to be a contributor who says that somebody's name and their actions are worthy of being on Wikipedia. So you can get an account to make a contribution, and I can decide that Valerie Mercer has done something that's notable, so she should have a page on Wikipedia. If I go and I stick that out there, is it going to stay? The answer is no. Thank you so much. Thanks for playing. And the reason why is Valerie has to be noted in multiple sources. And it doesn't necessarily have to be refereed sources, but she has to have something that's shown up in a newspaper, a journal, a refereed, some type of publicly consumed type of media. Okay? Let me give you an example. There is a gentleman in South Georgia who created a piece of technology that shells pecans. It does it really well. He went to all of the major agriculture makers and said, I've got this. I want to make it happen. Will you take my product? Let's do a patent and let's actually get it going. So Kubota says, oh, that sounds great. Let's do it. And Kubota is one of the major manufacturers that's out there in agriculture. And unfortunately, they said to this gentleman, put us a plan together. And since we like this so much, normally what we do is we take a utility patent and you sell us the rights to it. And then Kubota owns the patent for it. However, Unfortunately, this gentleman was in his later years and he passed away before this actual technology was registered as a patent and before it could be transferred to Kubota. To this day, it is the superior way to shell a pecan, but it has never been licensed and it has never been shown or used in a commercial product. So if you and I were going to Wikipedia, we would actually see pecan shelling products that have been publicized in magazines, journals, newspapers, those kinds of things, verified sources that it actually happened. And yet there is another better technology that's out there that never got realized and is never going to be on Wikipedia. So what I'm saying to you is the algorithm that Gemini, Claude, all of those things were built on is usually Wikipedia. That's one of the first things that they pick up. But it is not a full data set. There are so many people who have made achievements, or there have been historical events that weren't recorded and verified in multiple sources. And because that, Wikipedia is never ever going to be a full data set. Now, is it more of a full data set than we have ever had before? Absolutely. Okay, we've never had that. If you're like me and you live the life of the card catalog, then you had a book of knowledge at your house or a set of Encyclopedia Britannicas or some world books or those kinds of things. And that was the breadth and the depth of the knowledge in your life. And then Wikipedia came along, and there are other avenues like that. But we have something called survivor bias. The people who had success are the people or the events that happened that were memorable and recorded by major media make up most of our collective memory. And so therefore that algorithm set that we're thinking about is incomplete. That's survivor bias, okay? All right, so availability bias is another one that's out there, which is you and I are thinking about the ways that we have encountered things before. And let me give you an example of, well, it's got to be kind of controversial, but let's talk about global warming, okay? So we remember when things were cold, or we remember when a specific weather event happens, but you and I don't necessarily think about cataloging the temperature every single day that happens. And so that would be one of those selection biases or availability bias that's out there, okay? All right, so I love this little building machine learning algorithms. I love this display so that you can get a visual of the question and answer sessions that have to go. And this would take less than 1/10 of a second in order to make this actually happen. But these are the kinds of designs that are happening. And today, the algorithms and the machine platform-based learning platforms themselves are building the algorithms themselves and building these things. So the human part is coming out of this and it's building itself, okay? So the next steps for us. Any questions before we move forward? All right, so we want to talk a little bit about implementing algorithm awareness, some safety measures to take in terms of social media platform, and resources for you as you think about algorithms in your future. Okay, so you want to take us forward? All right, so we got some social media algorithms. Back in the day, good old Facebook, Grandma's network. How did that work? Do you remember?
I signed up when I was a college student and didn't have a college account or a college email address to sign up. So
Tell me about your feed back in the day.
there's all the parties happening around the college campus at the time.
Okay, and were they chronological?
It's a bit hazy.
He said the parties.
It was college after all.
Yeah, so I'm talking about your news feed, not the parties. The parties, I'm sure, were chronological, and you can count them anyways.
Sure.
But anyway, so up until 2008, 2009, Grandma's Network still worked on a chronological feed. And then through science, they were able to figure out, hey, wait a minute, we need to show them favorites. There are certain things that people are lingering over longer than others. And so therefore, we need to prioritize content, because what we want to do is monetize their presence on our platform, So we want them on the platform as long as possible. Are you to the point in Facebook Live, if you have one and you want to admit it, and I am, well, that you are getting items on your feed that look like something that's kin to what you've signed up to follow, but it's not the same thing? Okay, I'm getting a yes in the audience. Okay, so that is there. If you like things about Savannah, Georgia, then you probably going to like things about Charleston, South Carolina. So here you go. Here are a bunch of things about Charleston. If you're interested, we had a conversation about cruises out in the hallway. So if you're researching cruises, then hey, let's give you all the things you need to know about the Virgin Cruise Line, the Norwegian Cruise Line, all of the different cruise lines, even though you didn't ask for that. In fact, you may have looked at it outside of Facebook, and then you are getting all kinds of content inside of the platform. In your settings, you've actually allowed for that to happen. Meta builds a lot of its algorithms based on your physical location. They're also building your content based on what other people you know on the platform. So if you and I are friends on the platform and we are on the platform and you like quilting, but I don't have anything to do with quilting, I'm going to see some things about quilting. So this a kinship is going on simply so that we can keep everybody on the network as long as possible and monetize as much as possible. Okay. So let's talk some more about that. Social media algorithms are out there built for you and I to stay as long as possible. What's your social media platform of choice these days? LinkedIn? Okay, that's great. I love that. Gold star. So LinkedIn actually is a platform, and they have added videos as well as other things to keep you on their platform as long as possible, because there are people who are paying. They want to optimize that engagement as much as possible. How about Meta's products, such as other products besides Facebook? Anybody use Instagram? No? Okay, so Instagram has found its way into being the major competitor for TikTok. And they want to monetize more effectively that platform so that they can commodify what you are doing there, and giving them more and more ads is what they are always after. So take us to the next one. Here are some things that we want you to be aware of. Engage with content you trust and you want more of. Who's the author? Who made this? I've never heard of this thing that just popped up on my feed. Oh, wait a minute. I can always say I'm uncomfortable with this, or I'm not interested. Once you start curating your feed that way, then you're going to teach it and you'll have more control. Okay. Be guarded about the information that you share, because I have good friends who shared with the world this week that they went to the Eagles concert at the Sphere in Las Vegas. They also went to the Grand Canyon. They also went to all of these different places out west, and then they got all kinds of suggestions because they spent tickets for an Eagles concert. They must have money to spend tickets for this type concert, that type concert. They must have money to go to Canada since they went out west for that. So the platforms are doing what they can to make you share as much as you can. Be guarded with that when you do. The old-fashioned don't tell people you're out of the house on social media still rings true. If you limit info you provide about yourself, you limit extent to which the algorithm can target you. So if you are one of those lurkers that's out there, then it's going to try to get content about you. But if you're not posting on the regular, that's probably a safer thing. Don't accept the defaults. You should go through your settings and make certain that you know what X knows about you or what Blue Sky knows. Blue Sky is a little different if you haven't tried it. If you want to go back to an old-fashioned chronological feed, Blue Sky will let you do that. And it is a lot like Twitter in terms of word count and those kinds of things. So adjusting privacy and personalization settings can help you not be micro-targeted. In other words, somebody can't all of a sudden decide, hey, we want to push all of these ads to you about shoes because you go shopping for shoes online once a week, okay? I might be guilty of that. So off Facebook activity, make certain you go into your settings and you fix it so that it is not reading the content that you are engaging in outside of that platform, whether it's Facebook, TikTok, those kinds of things. You're going to go into your settings. I've done workshops with families and with senior citizens before, and I love them because they walk up to me after I get finished with my presentation and say, here's my phone, fix it for me so that I don't have any of these things happening. And I will walk them through how to get to it, but I don't normally touch people's phones. But I will say to you, be brave and make certain that you go in and read through what the settings are. Start with privacy, start with a checkup if that platform allows for that, and figure out a way that you can look to see if this is what the settings need to be, okay? So you know TikTok was going to pop up in our conversation. You'll take us to the next slide. So for us as college students and for college faculty, we are the demographics who actually use social media the most. I can tell you from having a 19 and a 22-year-old girl that they are on social media all the time. So what I encourage them and I encourage for you is to make some time to disengage and ignore any posts that you aren't afraid of or hide them or say you're not interested. Platforms will also let you say, I am not comfortable with this, or you can block certain keywords. So please be a fan of that and try it out. But I encourage mindful breaks from social media. When you do that, you're also going to see a cleaner feed, because that cleaner feed is going to be based on what you have set, and they know they're going to continue to try to attempt your engagement, but revise who you follow and make sure that the list coincides with what you want from your feed. So why am I following this person? They're always saying this, 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 and this. You don't have to, okay? And even if that's a family member, you can say, shut them off for 30 days or take a little vacation from them, okay? They'll never know, all right?
Ready.
And then one of the things that's offered by Consumer Reports is to create and maintain a security plan. We won't go into that today, but just know it's free. It asks lots of relevant questions for you as a consumer so that you can make certain that what you're interacting with in terms of algorithms is healthy and appropriate and contributes and supports your wealth as a consumer, okay? So that is out there at securityplanner.consumerreports.org, all right? And then if you want to click, right? It'll take us out to it. You don't have to click.
You want me to try it?
Yep. So I want to talk to you about some resources and things that you may be interested in if we've got you spurred or thinking about this. One of them is a book that has a 2024 copyright date, and that is Filter World, How Algorithms Have Flattened the Culture by Chaka. And then I have a variety of different things, including that Consumer Report Security Planner that I talked to you about. If you haven't read the book, Invisible Women, Data Bias in a World Designed by Men, it's great for men and women to read. Okay, scroll down for me. Awesome. And then I have a variety of different articles for you. The definitions that I shared with you for algorithms in and of themselves came from a book called Hello World, Being Human in the Age of Algorithms. One more scroll. And like I said, some very recent articles that will share with you some things going on with Google search and those kinds of things. All right, comments, questions, conversation?
So does the Schrodinger's cat phenomenon apply to social media and algorithm usage, that if I know how algorithms are treating me, then I'll purposely go out of my way to modify how the algorithms treat me?
I won't say that there's...
And so the data that comes back out of it is now tainted, that gets fed back in later on?
Sure, that's classic sandbagging.
Yeah.
So yes, just like platforms such as ChatGPT or Claude or Gemini, if you're mean to them or if you give them a question that's not respectful, some of those platforms are actually being built with anti-sandbagging types of things, It's the same thing with social media, which you may have to actually cleanse your palate, if you will, in social media and tell it, hey, I have a whole new set of interests and these are the things that I want to see. And so that may be a different way of handling that rather than trying to manipulate it. Just be, I want to move forward with these types of things and I want to drop my follows that I do for these things.
We have a question from someone who's watching online. There's a bit of context that I'll need to use. This may take a second.
Okay.
Research shows that AI algorithms are trained on biased data, and often there's not a single person who understands what the algorithm is doing because it has trained itself. Biased results decisions are only corrected when overt or obvious, and then the correction is just a matter of filtering results. The bias of the algorithm itself is never corrected. This means biased results continue to occur, and we might not even realize they're biased. Fixing this would require starting with a clean slate and new data/new algorithms. Will something like this ever happen, or are we doomed to biased algorithms forever?
And so Dr. Spangler?
No.
That's a great question.
Oh, I love the question. So what we are seeing is the fact that you will be able to create your own agents. And so we're seeing specialized fields that know that the overarching data sets for those large volume LLMs are biased, but there's nothing to say that you can't pick up a data set and go and cleanse it and make it your own in your own agent set. And that's what's going to be happening next as we see more and more specialized agents, whether it's you're in the real estate business or banking business or you're in the medical field. I suspect we will continue to have these LLMs that are out there, but we are also going to see more and more specialized agents and platform sets as well. Simply because there was an AI conference an international AI conference in Paris in the last week. And one of the things that was a big, huge factor in previous versions of that conference was user safety and platform authenticity and transparency, accountability, if you will. And this time, because folks were talking about the fact that they can make their own platforms and they can make their own little mini Gemini or their own whatever, the focus was not on that. It was on moving forward and how far can we push this technology. That's a very different mindset and a very different culture than this is dangerous and it's going to be detrimental to us. So I think you're going to see as the newness wears off, and the ability for people to make their own platforms and the ability for entities to make their own platforms, that we're going to see a lot of that kind of move off and not take as much center stage as it is right now. Okay.
We've had signs of more typing in the chat. Oh, thank you.
Thank you for who's being there. I love the question. Anybody else? Any other questions?
I would kind of agree with that. There's been some movement, I think, law enforcement and digital forensics to that extent, where especially like CSAM material is that the data set to identify CSAM material is built by actual CSAM material, so that when you build an AI LM on top of it, you sort of start taking the human element out. It's a lot more accurate in its identification, whereas
So,
the general data set may not be.
Right. And so I didn't circle back to my point about Robert Williams, who was arrested in 2020. He is a pillar of his community outside of Detroit, Michigan, and his subject or case study is part of my 4205 class. That's the reason why I said Dylan's heard this before. Mr. Williams is a father. He has 2 small children, a loving wife. He is involved in his church and his civic organizations. And he was accused of shoplifting in a store that he has never been in before. And by faulty facial recognition through an algorithm that should never have been used, Mr. Williams was arrested and spent 30 hours in jail. And to this day, there's still not a full resolution of the case. As of December of 2024, the ACLU and others were still trying to take this to court. Now, Mr. Williams is not the only person who's been faulty arrested like that. There have been multiple cases since then, including one of an Atlanta, Georgia man who was arrested in Louisiana for that. This clear view technology, which is used for the data set that makes that algorithm happen for facial recognition, is not regulated. And so we will continue to see how that progresses. But that is an example of an algorithm and its bias that's certainly out there and changing lives. We talk much more about that. If you want to learn more about it, Kashmir Hill has a book on that. And her name is Kashmir with a K, Kashmir. And Meredith Broussard, Broussard, has a work about that as well. So those are two examples. Now, let's say, who do you want to follow on social media about algorithms to learn more about it and be able to consume and feel good about it, having an understanding? Well, there's two ways to go. You can go follow a gentleman named Ethan Mollick, who runs the Wharton School of Business Lab for Artificial Intelligence. He and his wife do. And they have 20 people who work for them. And if you go look at his content, he is constantly pumping out content to the point where some days I feel like I'm having an AI fire hose waterboard experience. So I'm going to point you to somebody else if you need to curate your feed and give Ethan a little rest for a little while, hint, hint. I'm going to point you to somebody named Harper Carroll. She is a former Meta engineer and worked for the VR division of Meta and Facebook, and she actually runs her own independent lab now. Her videos on Instagram and TikTok are a little more palatable, and I don't feel like I'm having the science pushed at me. As a consumer, it's much more palatable to me for Harper and the work that she's doing in her lab. Okay, so that's my recommendation for you. If you want to have a takeaway that's easy, then simply add that to your social media feed. All right, any questions for me?
We just
Dr.
have
Blackburn.
more of the questions in the room. Just want to say online, there's a seconding of your recommendation of Invisible Women.
Oh, great. Yeah, it's a great book. Mm-hmm.
So in a previous presentation, you kind of talked about some of the mental anguish that can occur from social media and the polarization of the algorithms to certain feeds.
Mm-hmm.
You talked a little bit about taking a break, how the algorithms work by pushing the same information. Could you talk a little bit about some of the dangers of getting the same feeds over and over?
Absolutely.
Taking down a kind of a path that's
Sure, and the technical name these days would be a filter bubble. So the way that you want to make certain that you're not stuck in a filter bubble is the fact that you want to get opposing viewpoints. It's just like, I'll give you an example. YouTube TV at my house runs all the time. It's like a lamp that makes noise, okay? But if my mother and father have been at my house, then it has had Fox News on it, all right? And the first thing that's going to pop up in my list of things that have been watched is Fox News. I don't watch Fox News. I don't watch the news as a general rule, okay? I get my news from social media. But as we can see, the thing to do would be to also get in that line other news sources so that you get a variety of different things. It's the same thing with social media. And so that algorithm is working on YouTube TV to push what I'm normally watching or what it thinks somebody is watching. But my 82-year-old dad's viewing habits are much different than mine. And so that is one of the ways to get out of that bubble, is to welcome opposing viewpoints and to go look for things, curate your feed, if you will, again, so that you've got a variety of news sources that you feel comfortable with. And all of those are out there. You can even follow, there are lots of different providers on Instagram and TikTok who say they are unbiased purveyors of news. Jordan is my lawyer, is her handle, and that's one of them who's out there. Okay. Does that answer your question, Dr. Blackburn?
Thank you.
Okay, great. Anybody else? Dr. Steins.
Pro-regulation, or it's too soon to regulate AI?
It would be, so let's take an analogy. Pro-regulation, or it's too soon to regulate cars in 1914. And the reason why I say
Model T if I could.
right, the reason why I say that, at that point, when you go look at old pictures like that, you and I are used to cars right on the right side of the road, and there are sidewalks. And there are ways that we regulate, such as traffic signs and lights and those kinds of things. We didn't have those in 1914. But when you go look at a picture of New York City the week of Easter Parade in 1905, it's all horses and buggies. When you get to 1914, it's all cars, one horse and buggy on the street. And we're beginning to see the lines form, and we're beginning to see the actual sidewalks and things like that starting to happen in urban planning then. I think when you take that analogy into AI, that's where we are at this point. So where are the signs? Where are the traffic lights? Where are those things? Which would be regulations. I think that's going to happen with time. Because have we truly arrived in terms of understanding what it will do for us and how it will change what we do as a society? And that was a big question in 1905 and 1914 when we talked about cars. Okay, so taking it back to the analogy that I talked about, we can teach a recipe on how to make an apple pie to a platform, but can I teach it how, when it goes and looks in the mixer, the difference between mixing the wet ingredients and making it fluffy or just having it mixed together? Does it know what fluffy means? Well, that nuance is not where we are. And so let's get to that point. We will see. And I like following things like the AI International Conference that I just talked about, because tracking that theming that's going on, are we focused on safety or are we focused on progression? And to me, that just shares with us that we're not quite ready for the traffic lights and the stop signs and the other things that we're going to need, but eventually they're going to show up. Okay, other questions? That's just my personal opinion too, by the way. Any other things? All right, well, it has been a pleasure today. I want to thank Deborah Stanfield and Samanthan Wilcox, Dr. Blackburn, and Dr. Savanovic. Thank you so much. Thank you for our audience who came today and online. Thank you so much. All right.
And for those of you who are in the room